All the common package managers that are out there, like NPM, PNPM, and also Yarn, have a concept that is called workspaces. And such concept allows you to have multiple packages in the same area, in the same workspace, and you can link them locally together. Meaning you can have an application, you can have a library, you can also have multiple libraries, and you can consume them locally and reference them without having to go through a publishing step, such as like an NPM registry. And this is exactly what you usually want to have if you want to set up a monorepo. And so today in particular, we're going to have a look at PNPM, how a PNPM workspace is being set up, and also once we have that, how we can optimize it for speed and developer experience. So first of all, let's start and create a folder. Let's call it PNPM mono for monorepo, which is basically where we will host our monorepo application. And so then the first step we can do is just run PNPM init, and this will just create a package JSON that we can then use for the root level of our monorepo. So let's open up Visual Studio Code for this. So far in our workspace, we just have that single package JSON that we just created. And this is the root level package JSON for our monorepo. And I think like the main entry point here we probably won't need because all the actual applications or libraries will live in their respective folders. Let's leave the scripts for now, but probably we don't need those either. A good practice that we probably want to do is initialize Git here. And so let's create a Git ignore to get started. And then basically open this up and specify some of the most common things that you would usually have in there, which is like the node modules folder, which we don't want to have cached in Git or don't want to have committed to Git, this folder, and also potentially build folders. Those are usually the folders that contain the build output. And we can add more as we go, or we can also have that then individually in the apps or packages that we have in the workspace. Then let's init Git. And so now we have a new Git repository. So let's just add all of it and commit it. So let's now go ahead and actually structure our monorepo workspace. Now, monorepo workspaces most often come in two different shapes. There is like the app-centric setup, which has usually a folder structure with apps at the top level and then packages. And then there is the more like package-centric, which is very often used by open source frameworks. For instance, check out like how Vue.js or React.js or also Angular structure their workspaces. And that's usually a folder called packages where all the various packages live in there. You can have both structures, you can mix them. We will today go mostly with an app-centric structure where we have like a Remix application live in that apps folder and we have a React library living in that packages folder. So let's go and create that. So let's create an apps folder and then let's create also packages folder. And these two will be where our applications live in the end. There's something more that we need to do. So in order to tell PNPM that this is actually a workspace and we're not just using PNPM for installing our packages, we need to create what is called a PNPM workspace.yaml file. And this is created at the root of the workspace here. And we define basically what the structure of it looks. And so we have the packages that are living in this PNPM workspace basically live first in the apps folder or in the packages folder. And we probably want to have a glob here. So let's do something like this. And you could add here other folders as well. Or obviously, if you just have a package-centric monorepo, you would just have a packages folder in here. And this is basically just used for PNPM to understand where the packages that it needs to link locally within the workspace live. So let's actually commit that as well. And as the next step, we can already go ahead and create one of the applications that we're hosting in here. So we can host any type of application in our PNPM workspace here, whether that is like React, Angular, whether it's Svelte, or whatever you want to choose. Now in this specific example, I'm going with Remix. So let's just go to their website, go to the docs page and understand how we can create a new Remix application. So you can see here, there's the npx create remix at latest. So let's go here. We want to create that in the apps folder. So I'm cding into that. And then let's paste this in. Now I might want to change npx with pnpx, which is the equivalent just for PNPM workspaces. So Remix asks where to create the application, and we definitely want to do that in my Remix app because we are already in the apps folder. we just want to create the basics, so we don't need a pre-configured setup stack. And we can also just go with the Remix app server. Obviously, choose whatever best suits your needs. Let's also do the PNPM install, so it immediately sets up Remix and should be good to run. So let's explore what got created here. In the apps folder, you can already see now we have the My Remix app folder. This is a full Remix application that just got generated by their command. And there's a package.json, which is just the default package.json Remix comes with. Now, one thing we might want to do is add a name property here. So let's just call this My Remix app. This is because it will be used by PNPM workspaces when we address commands against it. Here are Remix specific scripts that we can run, for instance, for building, developing, or just starting a Remix application locally. And we can directly invoke them here. So we can just cd into My Remix app here and then run PNPM run dev. And this would kick off this script and run Remix locally. So we can actually go to localhost 3000 and we have our Remix app running. Now, usually what you don't want to do is like cd into every application or package you want to execute or run a command against, but rather you would want to run this from the root of the monorepo. So let me just go back out to the very root of our monorepo. And for this purpose, PNPM has so-called filter commands. So what we can do is we can run PNPM -- filter. We can give it the package name, which in our case is My Remix app. And this basically uses the package name specified in the package.json. And then we can run the command or issue a command against that application. So in our case, that would be dev. And you can see it does the exact same thing as before, just that now we can do it from the comfort of the root of the monorepo rather than having to cd into the single package. So now that we have the Remix application running, let's actually create a small shared library that we can then consume from within that Remix application. So again, what we do is we just go into that packages folder here and we create a new package. So our libraries or packages you live inside this packages folder. So let's create something that is called shared UI. And the main goal here is that we would want to have like a shared UI library, for instance, that can be consumed by different applications that live in the monorepo. So let's actually cd into that packages shared UI and let's do PNPM init again, which will create a package.json for us. And so we can go ahead and customize it to our needs. So this is name shared UI. Again, this will be a private package. This could totally also be a public package if you intend to actually publish that to some NPM registry, which is totally fine. You can have a package just live locally. You can have a package also live locally as well as being published for being consumed outside the monorepo, which is a totally valid use case. For the rest of the things here, let's just leave them for now as is, and we will then tune them as we progress. Now, what I want to do here is I want to create a React package, and we want to probably use TypeScript and also just use the TypeScript compiler to compile it for sake of simplicity here. So let's install those dependencies. Just issue PNPM add, create a filter again, and say shared UI. And I want to install React. And I also want to install TypeScript. Let's actually pass the -d here because TypeScript will be a development dependency, not a runtime dependency. And so now you can see how we have the dependencies set up. And note this is the local package.json of our shared UI library here. So now let's create something useful. Let me create a button component. Let's call it button tsx file. And let me paste in here a button implementation. So this is a very simple one. You can see here is a button element with an on-click handler, which we can pass in. Nothing really fancy, but it works for our small demo purpose here. Another thing you also want to use in a monorepo, usually in those shared libraries, is to have a common export. So as your public API of the library, basically. And so this is usually the index.tsx file where you can explicitly export things from that library that can be consumed by other libraries. Because potentially you could have some components, React components, or some other logic that just is tied to that specific package. And so you would want to have it local rather than exposed to the whole world. And so here we can now export everything from our button component because that's what we're going to use from the outside. And so with that, we should be good to go. Now, another thing we want to set up is the compilation. For this simple purpose, I'm creating just a TypeScript setup So we use the TypeScript compiler that will compile it, the single files, and they can then be consumed. Note, the goal here is not to create a fully real-world proof compilation output of a React library. You would want to use some more sophisticated setup for that purpose. So in this case, let me just paste in here our TypeScript setup, and we will place this in the tsconfig.json. Another note is also that many of these things, as we have specified here, you would probably want to abstract into a higher level tsconfig and reuse it across different packages. So keep that in mind while you set up your monorepo. Now here there's nothing fancy. We have some JSX stuff. We have the module set to CommonJS because that is what our Remix app will consume. And we have here the output set to a dist folder so that we have everything grouped into one place. Now, having set up that, we want to also adjust our package.json because now the main entry point will live in that dist folder. So we want to set that to dist index.js. And we also want to change here this test script, which we don't use right now, to a build script. And what we do here is just delete what has been created before and then just invoke the TSC compiler. And so with that, we should be ready to already test that. Again, we can use PNPM filters to target the shared UI project in this case, and then invoke the build target. And we should spell this correctly, otherwise it wouldn't work. And now we can see we got that dist folder output here, which contains our button.js, which is now compiled to JavaScript. And it also contains here our index.js, which is the one that we are going to consume. So far we're set up. Now we can go to our Remix application, actually install our shared UI package and then consume it. So first step, let's install the shared UI package in our Remix application. So to install our shared UI package, we could go to our Remix application package.json and just manually add it here. Or we can also use the PNPM add command and target that to our Remix application. So we can say PNPM add shared UI. We filter and give it the My Remix app. And we can also pass the workspace flag here, which means the package needs to exist locally in the workspace, otherwise PNPM will error. And so we install our package. If we now go to the package.json, we can see that this shared UI dependency has been added in our dependencies part here of our package.json. Now, we probably don't want a specific version, but usually always want to rely on the latest version. And you can also see this workspace part here in front, which is a specific protocol to that PNPM workspace setup, which indicates to PNPM that this package lives locally within this workspace. So how does it work? If you go to the node modules folder, you actually see that our shared UI package is in here and it has been linked to our local shared UI package here. So this is basically a symlink which connects the two packages together. And so with that, we can actually now go into our Remix app. We can just go into a specific route here. And let's just actually remove everything that is in here because we don't really need this. Let's create here a div, and then we want to use our button. And so we can just go ahead and import the button from our shared UI package and use it in here. And we can provide it here a click handler, which is on click, which would then just do something like console.log. Let's try and see how this works. Again, let's run our My Remix application. We can use PNPM --filter, My Remix app, and run the dev target. And so this will now install the package and run Remix. We can go to localhost 3000 and refresh. And now we see our Remix package loading the button, and the click handler worked properly. So far we have seen the PNPM add and filter commands. Now you can also run multiple commands against the entire monorepo. So for instance, let's say we want to run the build for all the packages that are present in the monorepo here. We can use something like PNPM run-r for recursive, and then say the command that we want to run. So in this case, this would run the build on the shared UI package as well as on the Remix app package. Similarly, we can also add here a parallel flag. And now the commands will be run in parallel. So to recap, to set up a PNPM workspace monorepo, all we need to do is actually define the structure of our monorepo. So whether we want to have an apps and libs folder or apps and packages or just a packages folder. And then we need to create a pm-workspace.yaml file, where we tell PNPM what our workspace looks like. And from then on, we can just use the normal setup of the applications that we set up within the workspace. So basically for Remix, we went to the Remix docs, copied their command, and then set that up within the apps folder. And similarly for shared packages, such as our shared UI package, we can just use the setup we are accustomed to for building our libraries. This could be just a simple TypeScript setup as I have done in this demo here, or we could also go ahead and just use some more sophisticated things like Vite for running it, or ESBuild or SWC. So this works fine as long as your workspace is relatively small, but as you grow your Monorepo, you might want to have more sophisticated features for running tasks within it. That comes with better developer economics, but also like things like running things in parallel, only running things incrementally what changed in a given PR, and also things like caching to make sure that you scale even as your workspace grows. So let's have a look how we can do that in a very straightforward way by using NX. So if you haven't committed the changes yet, this is a good moment to do that and add that to our Git repository. So to install NX, all we need to do is use PNPM add, give it a package name, which is NX, -d because it's a development dependency. And we also pass -w because we want to install it at the root of our workspace, because this is not dependent on specific packages, but rather we want to use NX to coordinate and orchestrate the execution of the commands across our packages. So this will live at the root package.json. In fact, if we go now to our root package.json here, we will see that we got a new development dependency, which is NX with the version that is currently the latest. So with this, we can already start using NX instead of the PNPM commands to run tasks in our Monorepo here. So rather than doing PNPM --filter shared UI or whatever we want to target, we can just use npx NX. Note the npx in front is just to reference to the local NX installation within the node modules folder. And so I'm running npx NX. We give it the command that we want to run, which is, for instance, build, and then the package we want to run it on, which is shared UI. And NX automatically figures out how the workspace structure looks like, it finds the package, and it runs the script in the according package.json. Similarly, we can just do NX dev remix for the My Remix app, and this would just run the dev command that is present in that package and run remix at localhost 3000. Now, one of the main features of NX is its caching. It allows you to cache an operation and you don't have to execute it again if the input sources didn't change. And this is actually what speeds up your Monorepo quite dramatically. Now, by default, NX does not cache any operation, just to be cautious, because potentially operations could not be cacheable. So what does a cacheable operation look like? It is like a side effect-free function. So whenever you get a certain input, you get always the same output consistently. Let's have a look how to configure that with NX. So first of all, we create an nx.json at the very root of our Monorepo to contain that configuration. And let me paste in here some simple configuration. This is the task runner configuration for NX. So it tells 10x which runner it should use. You could potentially switch them out and have different ones, even in different environments. And then there's a key part here, which we actually want to do now, is the cacheable operation setting. And so for our specific case, what we want to cache is our build. Usually you would also want to cache something like test or linting, but since we don't have any of those scripts in here right now, we are not adding them for now. So now, given that we have added that cache for the build, we can actually try it out. We can run npx nx build shared UI, and you will see now it runs the build again. It took about a second. Now, if I rerun it, it is immediate. So you can see the whole operation took like 6 milliseconds. And you can also see this note here, NX read the output from the cache instead of running the command 1 out of 1 tasks. And the output, however, is exactly the same as before. As you can see, NX just restores the same output. It also restores the cached artifacts, such as our dist folder. If I'm going to remove the dist folder and run it again, you can see how it is being restored and our files are still there. So NX uses a couple of defaults for where usually the output is placed for such build commands. But obviously you can configure that. Another thing you might to customize is how NX computes the cache. So basically for every operation that is being executed, NX creates a so-called hash out of the inputs that got contributed to that operation. And it then uses that hash again to invalidate that cache if some of the input changes. Now, looking at the input files here specifically, NX by default just uses all the source code files that live in our repository, in our shared UI package here. However, that might have some undesired side effects. For instance, let's create here a readme.md file. Hi there. Now let's run the operation again. Let's run npx nx build shared UI. And so you can see now it gets recomputed because we changed our source code. However, if I rerun again, it gets cached. Now the thing is, if I go here and create another exclamation mark, so I change the readme.md file, and then I run the shared UI build again, it will not be pulled out of the cache, but rather it will be recomputed. Same thing goes if I have test files in here and I change the test files. Now for a build output, however, I probably would not care necessarily about the changes in the README file, or I would not necessarily want to recreate the build output just if I change some test files. So in order to customize that, we can again go to the NX.json and we can add here what is called target defaults. Target defaults allow us to specify default configuration for our packages that live in the workspace. And so in this case, I want to create a target default for our build scripts that live in our packages. And what this does is basically it allows me to pass in defaults for things such as like here the build script, as well as the build script also for my package in the Remix application here. And what I want to customize specifically is the inputs. And as the inputs here, I can provide globs. And so in order to disambiguate the paths here, I have some placeholders such as like the project root. So for our shared UI package, that would be basically packages / shared UI / and whatever I specify here. And I would want to target all .md files, and I would want to say I want to not include them in my build. So now let's see again. Let's rerun the shared UI. It will rerun the first time because we changed some essential files such as the NX.json configuration. It will cache the result the second time. Now if I go to the README and I change something here and save this again, and then I rerun the command, you can now see it is still being pulled out of the cache. So NX now ignores that markdown file and therefore doesn't invalidate the cache if we change a markdown file for the build command. It would still change it for, let's say, like the serve command, because it might be useful for that, or for the publishing command, because for publishing, we want to have the updated README included in the actual output. Now, since you might want to reuse such inputs across different targets, let's say we have another one here that is called test, and we also want to make sure that markdown files don't invalidate our test runs, you would duplicate them, but you can also do better by using here such a named inputs section. And the named input section is nothing more than a section where we can define reusable inputs. And so we can say something like no markdown, and we can just copy the same configuration here to that no markdown configuration up here. And then here, rather than using the final glob, we can actually reference now that no markdown configuration from up here. We can even do more to say this doesn't just hold for the specific build command of our own project, but also all its dependent projects. And so we can basically prefix that with no markdown and the head in front, so that sign here, and express that it would also hold for all inputs of our child libraries that we depend on. So basically our Remix app depends on a shared UI, and so it would also hold for that one. And then we can also copy that over here, and you can see how we can now reuse such globs and just change them in a central place in that named inputs section. So alongside these inputs, you can also provide outputs if they differ from the default ones that NX comes with. And so we can just go ahead and either provide an empty array here, which indicates to NX that this specific operation does not have any outputs, which would then help optimize the actual restoring of the cache artifacts. Or alternatively, you can just provide some glob or path pattern, such as like instead of this, you call it build or something different. In our case, we don't need it because like we have the default output paths that NX comes with. So another common thing you have in PNPM workspace or monorepos in general is task dependencies. Meaning if you run a build or dev command, for instance, as in our case, it would depend on the output of some other task. For instance, if we go to our remix application, we know that we earlier referenced our shared UI package, which internally links again to that shared UI. And since the package JSON for that referenced the dist index.js output, that one needs to be present when we run our remix application. Now let's have a look what happens if we remove that dist folder. If we go and run our remix application, and we can use nx for that, so we use nx dev my remix app, it just boots normally, but then if we refresh it in the browser, we can see an error here. And it basically indicates that in this index.js file is missing. So how do we fix that? Well, we need to run the build for the shared UI package first. So this built it, in this case actually restored it from the cache. Now if we run our remix app again, it would work just as we expect. Obviously, we don't want to do that manually every time we change something. And so we can set up such task dependencies. And we can do that in the target defaults here. So we can go to the build command here and say that this one depends on not just the build command of the specific project, but also on the build command of all its child project or dependent projects. And we can indicate that with the symbol in front here, just as we did before for defining the inputs of our dependent projects. And we would want to have a similar thing also for our dev command. So whenever we run remix in dev mode, so we would also want that whenever we run a dev command, for instance, for our remix application, it would first run the build on all the packages it depends on, in our case, shared UI. So now having that, let's actually remove the shared UI package dist folder again. Now let's run again, or let's better serve our remix app. So what you see now, nx here prints out that it's running a target dev for project my remix app and one task it depends on, which is our build command. And in fact, you can see it runs first the shared UI build, and then it runs the dev of the remix app. And so if you go to our browser, refresh, we can see it just works as we would expect. Now, such sophisticated caching actually helps a lot in speeding up the operations either locally, but also in CI. But what you also want to do is you don't even want to run cache hits against something that didn't even get changed in a given PR. So to simulate that, let's create a small package that doesn't really do anything rather than printing out something to the command line. And so let's create here my custom feature, which is just a new package that we have in here. And let's actually cd into that packages folder and create a package JSON in there. Now we don't really do anything. We can remove here the entry point, and all we want to do here in the script, for instance for the build, is we want to print out an echo here saying building. And so now again, if we do npx nx build my custom features, it would just run that echo. So behind the scenes, nx creates a project graph over for your Monorepo. So let's go ahead and open that graph, which we can do by using nx graph, which will open up a browser window, which is showing an interactive version of our project graph here. So you can see now there is the remix application, which depends on the shared UI, and there is our my custom features library. It doesn't depend on anything, and no one depends on it. That dependency graph is also interesting because you can actually see why such a relationship exists by clicking here on the edge. You can even go ahead and do some more advanced filtering by saying, I want to start on this one here and I want to understand how the connection between those two exists and why that exists. Now, this is obviously a very simple example, but in a larger Monorepo, this is very interesting to just find all the paths or basically just the shortest path between two different libraries. So why am I showing this? Mostly because our workspace visualization here can help us understand what we need to execute when we change something. So meaning if I change my shared UI package, I want to also make sure to run, for instance, tests against my remix app. But I don't actually have to touch my custom features package because that didn't get changed and is not involved in any of these operations or linked to any of these packages or applications. So how does that work? If we go back here and actually commit this to Git, and then let's say we create a different branch, my feature, and we start changing some packages in that branch. We could go, for instance, to our button component here and just insert a new console log. So if we now add that to Git, and commit this, we can now use the affected commands to just run them against the packages that got changed. And so this is done by using nx affected, colon, and whatever command we want to use. Now to get started, we can also apply this to the graph. So let's start with that one first. You can now see it shows here a show affected projects rather than just a show all projects. And if you go here, we can already see that just the Remix app and the shared UI package got affected. So we changed the shared UI, and therefore also Remix app is affected by that change. If we again show all projects, we can see the My Customs features is not being considered and will not be used for running targets against it. So going back, let's actually run some useful command, and we can run the build command in this case. And you can see that it runs against the shared UI build and also against the My Remix app build. So in this way, we can avoid running commands against projects that didn't even get changed. Obviously, also this operation gets fully cached, and so you can see the output is being restored just the same as it did before. You get a note here that this was fetched out of the cache, as well as at the end, you can see 2 of 2 tasks got fetched out of the cache. Another thing you might have noticed while running this is actually that dynamic terminal output. If you remember before, when we ran PNPM run in parallel, the output would be interleaved. So you can see there's one output for the Remix app, then there's a couple for the custom features app, then again Remix app. So it's kind of hard to parse, specifically if you have like 50 or 100 projects in the same PNPM workspace, which is totally not like unrealistic. So when we run the same command with nx, in this case using affected, or we could also use the run many command. Say we want to target the build and we want to run it for all projects. We could even filter it just to a couple of projects, but let's just run it for all to see the dynamic terminal. You can see how the operations at the top here is what got already executed, while at the bottom you can see what gets executed in parallel dynamically. Now in this case, again, these two have been fetched out of the cache. My custom features build, which just echoes, has not been fetched out of the cache, but it doesn't show us any logs that are not relevant for our current operation. So to recap, what we have done is we have set up a full PNPM workspace monorepo from the ground up. We have configured it with using the PNPM workspace YAML. Then we have added nx, which is really just installing the nx package here at the very root package.json of our workspace. And we have done some fine tuning on nx by using well-defined inputs and also defining such a build pipeline or task dependencies using the depends on flag. So if this sounds interesting, subscribe to our YouTube channel. We will have more of such content in the future. Also, make sure to check out our Twitter account where we push out news and infos around monorepos, front-end tooling, and JavaScript.